Indices are algebraic expressions where we have what we call a base and a power. Indices, we are talking of algebraic expressions where we have what we call a base and a power. For example, x to the power 2. X to the power 2. Now, if it's one like that, we call it an index. If it's one like that, we call it an index. But then when there are many, that's when we call them indices. Now, every index has a base. A base is that number or variable. And every index has a power. So those are the basics. Those are the basics for this topic. Now, there are different questions that you can get on indices. Now, to solve indices, there are 8 rules that you have to know as a student. There are 8 rules or laws that you have to know as a student that you are going to use in your indices questions, just depending on the question that you are going to be given. Now, I'll start off with the first rule of indices. The first rule of indices says, if you have a to the power m and you are multiplying it by a to the power n, then you should get a to the power m plus n. I think you can see there now. Your a is your base. Your a is your base. So what this rule is saying is, if your bases are the same, and you are multiplying, your final answer should have the same base, but then you will have to add your powers. I'll repeat that. This rule says, firstly, for you to use it, your bases, they have to be the same. They have to be the same. They have to carry the same variable, or they have to carry the same coefficient, or they have to carry to be the same constant. So your bases, they have to be the same. And if your bases are the same, the rule says it means even your final answer should have the same base. And your final power should be a sum of your individual powers in the indices that you have. For example, let's say I have x squared. I'm multiplying it by x to the power 5. So the rule says, since my base is x, so it means even this side I should have an x. Then my power, it means I have to add my powers. So my power, I'm going to add the 2 plus the 5, and the 2 plus 5 gives me a 7. So which means the final answer is x to the power 7. I'll do another example there. Assume we have 2y to the power 3, and then we are multiplying it by 4y to the power, let's say 6. So I think you can see that our bases are still the same. Our bases are still the same. So it means our final answer is still going to have a base of y. Our final answer is still going to have a base of y. But now, because you have coefficients here, so it means you have to work out those coefficients. You have to work out those coefficients. So it means you are multiplying the 2 by the 4. Multiplying the 2 by the 4, we get an 8. So you put it there. So your 8 is going to be the coefficient of y. Then now we go to our powers. Then we add our powers, 3 plus 6. 3 plus 6 gives us a 9. So it means your final answer is 8y to the power 9. That's how we use that first rule. Now, let's go to the second rule. The second rule says, if you have a to the power m and you are dividing it by a to the power n, then you should get a to the power m minus n. Now, we can look at these indices. Our base here is a, our base here is a. So it means our final answer should have a base of a. So what this means is, if your bases are the same and you are dividing, if your bases are the same and you are dividing, your answer should have the same base, but then you should subtract your powers. For example, let's take x to the power 6 divided by x to the power 3. Our bases are the same. We have an x here, we have an x here. So it means our final answer should also have an x. And then as for the power, it means we have to subtract our powers. 6 minus 3. Then that gives us x is equals to 3. That's what this rule is saying. Then the third rule says, if you have a to the power m and then everything is raised to the power n, then you're going to get a to the power mn. I think we can see now that we now have one base. However, we have 2 powers. The other power is inside the bracket and the other power is outside the bracket. So what the rule is saying is, if you have 2 powers, the other one is inside and the other one is outside. So you're going to multiply those powers. The base remains the same. However, the power is going to be different. You multiply the powers. For example, let's say we have x to the power 7 raised to the power 3. Then our final answer is going to be x to the power 7 times 3. 7 times 3 is 21. That's what it means. Another example, let's say we have 2x to the power 2x squared to the power 3. 2x squared to the power 3. Now, for this one, you have to be very careful because your x now has a coefficient. Your x now has a coefficient of 2. Now, there is a 1 here. There is a 1 there, but the 1 is not written. So it means you are going to multiply that 1 by the 3. So it means you're going to have your 2 there. Then you take the power of the 2, which is 1, and multiply it by the outside power, which is 3. So 1 times 3, you get 3. Then you go to the x. X 2 times 3, you get a 6. Then we don't end there because we can actually solve this. You can actually use your calculator to find 2 to the power 3. 2 to the power 3 is an 8. So it means you have your 8 there, then x to the power 6. That's rule number 3. Then rule number 4. Rule number 4 says, it's a fairly simple one, this one. A to the power 0 is equals to 1. What this means is any variable, any number, any base, if it is raised to the power of 0, you get a 1. Any number or any variable, any base that you have, if you raise it to the power 0, you get a 1. So, for example, what this means is x to the power 0 is 1. 2 to the power 0 is 1. 100 to the power 0 is 1. 3,000, any number, 3,000 to the power 0 is 1. Any number, any variable raised to the power 0 is 1. Any number, any variable, any base raised to the power 0 is 1. That's how simple that rule is. Then let's go to rule number 5. Rule number 5 says, if you have a negative index or an index that has a negative power, you're going to get 1 over a to the power n. So what this rule is saying is, what do you do if you have a negative power? How do you convert an index that has a negative power? How do you convert it to become positive? So the rule is saying, for you to convert a negative index, you're going to get a fraction. Now, there is a 1 here, but that 1 is not written. So that 1 is the one that is going to become your numerator, or the coefficient of your base becomes your numerator. Then from there, you take your base, it becomes your denominator. You take it together with its power. That's what it means. Then, for example, if you have 2x, if you have 2x to the power negative 3, if we want to write it as a positive index, I'm saying these two, the coefficient of your base, the coefficient of your base becomes the numerator. Then from there, you take your base becomes the denominator. Now you take the base together with its power. So the power here is a negative 3, but then when it gets here, it becomes a positive 3. Then that's how we do it. That's how we convert a negative index to a positive index. Then I'll do another example to make life easier for you. Let's take, for example, 6x to the power negative 4. 6x to the power negative 4. We have a negative index. So I'm saying the first thing, the coefficient of x. The coefficient of x becomes the numerator. and then your base together with its power becomes the denominator. Your base together with its power becomes the denominator. But look at what happens to the power. The power is negative. Then when it gets this side, it becomes positive. We had a -4. So when it gets there, we have a +4. So that is how we use our rule number 4. Then let's go to rule number 6 rather. Rule number 6, A times B multiplied, A times B, everything raised to the power M, we get A to the power M multiplied by B to the power M. Now, what this rule is saying is, if you have two numbers or two variables and they are raised to a certain power, they are inside the bracket and they are raised to a certain power. So that power raises everything that is inside the bracket. It raises everything that is inside the bracket. So, for example, let's take, for example, C multiplied by D, then everything raised to the power 2. What that means is the 2 raises everything that is inside the bracket. The 2 raises the C and the 2 raises the D. So it means we are going to have C squared multiplied by D squared. Then another example, let's say we now have 2F squared multiplied by 3G to the power 4. Then everything raised to the power 2. This one is a little bit complicated. It looks a little bit complicated, but the concept is the same. It's just that we now have powers inside the brackets, and then we have another power outside the bracket. But the concept is still the same. So if you have something like this, first you are going to work out your coefficients. You are first going to work out your coefficients. So 2 times 3 gives us a 6. Then, yes, 2 times 3 gives us a 6. Then we now have an F there. Then for F, there is a power of 2. There is a power of 2 there. So it means you're going to take that power of 2 and multiply it by the outside power. So 2 times 2, it is going to give us a 4. Then you do the same thing for G. G has a power of 4. So you take that 4 and multiply it with the outside power, which is 2, and then you're going to get your 8. That's what this rule is saying. Rule number 6. Then let's look at rule number 7. Rule number 7 says, if now you have a fraction, and your fraction is raised to a certain power, then the rule says you're going to get A to the power M divided by B to the power M. What this means is the power outside your bracket, it then becomes the power of everything that is inside the bracket, or alternatively, the power outside the bracket. It raises everything that is inside the brackets. For example, if we have x, y to the power 2, what this rule is saying is we are going to have x squared over y squared. The power 2 is going to raise everything that is inside the bracket. Another example, if we have, for example, 2x to the power 3 divided by y, then everything raised to the power 2. The rule says, first things first, there is a 1 here, but the 1 is not written. So you have to remember that there is a 1 there and the 1 is not written. So it means the power 2 that is outside, it raises everything that is inside. So it means we are now going to have 2 to the power 2, then x to the power 6, everything divided by y to the power 2. Where do we get the x to the power 6 from? We get the x to the power 6 from 3 times 2, we get a 6. Then the 2 to the power 2, we get it from the power 2, we get it from 2 times 1, we get a 2. Then simplify your expression. 2 to the power 2 is 4. Then you are still going to have your x to the power 6 there. Then everything divided by y to the power 2. Then the last rule says, if you have a to the power m over n. Now, what this rule is saying is, now your power is a fraction. Your power is a fraction. So it says if your power is a fraction, so it means you are going to get root of a nth root of a to the power m. What this means is, let's take, for example, x to the power 2 over 3. X to the power 2 over 3. 2 over 3 is a fraction. No, now what this means is, to convert this, we are going to open the root sign. We are going to open the root sign. And under the root sign, we are going to put our base. Our base in this case is the x. Then it says, you are then going to take your denominator. Denominator is going to be your root. So it means you're going to take the cube root there, the cube root of your x. So it means you put your 3 there, then everything raised to the power of the numerator, which is 2. That's what it means. Then that's it. Then let's do another example. Let's say you now have 2x to the power half. 2x to the power half. Then you want to convert that. So the rule says for you to convert that, we first start off by opening the root sign. Open the root sign. Then under the root sign, we put our base, and our base this time is 2x. So we put our 2x there. Then we go back to our power. Our power is a fraction. So we say we take the denominator and make it the root. So the denominator, we put it there. Then everything then raised to the power of the numerator. The numerator is 1. So it means you're going to raise everything to the power 1. Now, mathematically, we don't write these 2 because that is the square root. So square root, we don't write the 2. So we just leave it like that. So these are the 8 rules that you need to know as a student for you to help you to answer every indices question. So believe me, trust me, every indices question that you are going to meet, you're going to use any of these 8 rules that I've just told you about. You are going to use any of these rules. So it's important as a student to try by all means to memorize or know these rules by heart or keep them tight in your mind.